Welcome to the podcast. On this episode, we're talking with three engineers, Tim Fogarty, Evgeni Dobranov, and Varsha Subrahmanyam. These folks are from the Connectors and Translators team, and they're responsible for tools like the BI Connector, which helps you map SQL queries to MongoDB. So if you're using a tool like Tableau or Qlik, any BI tool that leverages SQL, the BI connector sits between the BI tool and MongoDB to translate those queries so that you can effectively use those tools. We learn how that works, how it's written, how it's designed. We also talk about mongomirror, which is a migration utility that helps you migrate your data from outside MongoDB into MongoDB. I really enjoyed this conversation, and I hope you will too. Before we get to the podcast episode, I want to tell you folks a little bit about an event that's happening this week. It's Thursday, December 3rd, and it's called MongoDB Late Night. It looks like a blast. It's modeled after a late night television game show where you'll have trivia, you'll have a home shopping network, you'll have mixology, all sorts of fun things happening, and you have the chance to win some swag. So I hope you'll join us on Thursday, December 3rd, 5 p.m. to 9 p.m. Eastern Time. It's going to be a blast. If you want more information, head on over to bit.ly/MongoDB Late Night, all one word, bit.ly MongoDB Late Night. I'm sure you'll have a blast. Hope you enjoy the episode. Thanks.
You're listening to the MongoDB Podcast.
MongoDB Podcast?
Exploring the world of software development, data, and all things MongoDB. And now your hosts, Michael Lynn and Nick Raboy.
All right, welcome back. Today we're talking about connectors and translators. And you might be thinking, wait a minute, what is a connector and what is a translator? We're going to get to that. But first, I want to introduce the folks that are joining us on the podcast today. I guess we'll go around the Zoom room. Varsha, would you introduce yourself?
Yes. Hi, my name is Varsha Subrahmanyam. I'm a software engineer on the Translators and Connectors team. I graduated from the University of Illinois at Urbana-Champaign in 2019 and was an intern just at MongoDB just before graduation. And I returned as a full-timer the following summer. So I've been here for 1.5 years. And it's been great.
Evgeni?
Hello. My name is Evgeni Dobranov. I'm more or less right alongside Varsha. We interned together in 2018. We both did our rotations just about a year ago and ended up on Connectors and Translators together. And I went to Tufts University and graduated in 2019 also.
And Tim, welcome.
Hey, Mike. Yeah. So I'm Tim Fogarty. I'm also a software engineer on the Connectors and Translators team. I actually work for MLab, the MongoDB hosting service, which got acquired by MongoDB about 2 years ago. So I was working there before MongoDB, and now I'm working on the Connectors and Translators team.
Fantastic. And Nick, who are you?
I am Nick, and I am Mike's co-host for this fabulous podcast on the developer relations team at MongoDB.
Connectors and translators. It's a fascinating topic. You know, we were talking before we started recording, and I made the incorrect assumption that connectors and translators are somewhat overlooked and might not even appear on the front page, but that's not the case. So, Tim, I wonder if I could ask you to explain what connectors and translators are. What kind of software are we talking about?
Yeah, so our team works on essentially 3 different software groups. We have the BI connector, or the business intelligence connector, which is used to essentially translate SQL commands into MongoDB commands, so that you can use it with tools like Tableau or Power BI, those kinds of business intelligence tools. Then we also have the database tools, which are used for importing and exporting data, creating backups on the command line. And then also mongomirror, which is used internally for the Atlas Live Migrate function. So you're able to migrate a MongoDB database into the MongoDB Atlas cloud service. The connectors and translators, it's a bit of a confusing name. And we also have other products which are called connectors. So we have the Kafka connector and the Spark connector, and we actually don't work on those. So it's a bit of an awkward name, but essentially we're dealing with backups, restores, migrations, and translating SQL
So you mentioned the BI connector and Tableau and being able to use SQL with MongoDB. Can we maybe take a step back and talk about why somebody might even want to use a connector, whether that be the BI one or something else with MongoDB?
Yeah, so I can speak about that a little bit. The reason why we might want to use the BI connector is for people who use business intelligence tools. They're mostly based on SQL, and so we would like people to use the MongoDB query language. So we basically have this translation engine that connects business intelligence tools to the MongoDB backend. So the BI connector receives SQL queries, and then the BI connector translates those into SQL, into the MongoDB aggregation language, and then queries MongoDB and then returns the result. So it's very easy to store your data in MongoDB without actually knowing how to query the database with MQL.
Is this in real time? Is there a delay or a lag?
Maybe Evgeny can speak a bit to this. I believe most of this happens in memory, so it's very, very quick. And we are able to process, I believe at this point, 100% of all SQL queries, if not very close to that. But yeah, it is very, very quick.
So if I've got an infrastructure in place where I'm leveraging a BI tool and I want to make use of the data for an application that leverages MongoDB on the back end. That sounds like a popular use case. I'm
Right.
curious about how it does that. Like, is it just a straight translation from the SQL commands and the operators that come to us from SQL?
So it kind of works like, so if you've heard of transpilers, they translate code from one higher level language to another. Regular compilers will translate high level code to lower level code, something like assembly. But the BI connector acts like a transpiler where it's translating from SQL to the MongoDB query language. And there are multiple steps to a traditional compiler. There's the front end that basically verifies the SQL query from both a semantic and a syntactic perspective. So kind of like, does this query make sense given the context of the language itself, and then more granularly, the database in question. And then there are two more steps. There's the middle end and the back end, and they basically just, after verifying the query is acceptable, will then actually step into the translation process. And we basically, from the syntactic parsing segment of the compiler, we produce this parse tree, which basically takes all the tokens, constructs a tree out of them using the grammar of SQL. And then based off of that, we will then start the translation process. And there's something called pushdown. If Evgeny, you want to talk about that.
Yeah, I actually have not done or worked with any code that does pushdown specifically.
Oh, sorry. I can
Unfortunately.
talk about that then.
Yeah, might better for you. Yeah.
Yeah, so in pushdown, basically, we basically have this parse tree, and then from that, we construct something called a query plan, which basically creates stages for every single part of the SQL query. And stages are our internal representation of what those tokens mean. And so then we construct kind of like a linear plan. So, and this gets us into something called pushdown. So basically, let's say you have I suppose, like a normal select query. The select will then be a stage in our intermediate representation of the query. And then slowly we'll just translate every single token into the equivalent thing in MQL. And we'll do that in more of a linear fashion. And then slowly we'll just generate the MQL representation of the query.
Now, there are differences in the way that data is represented between a relational or a tabular database and the way that MongoDB represents it in documents. Is there, I guess, through the pushdown and through the tokenization, you're able to determine when a SQL statement comes in that is referencing what would be columns. There's a translator that makes that reference field.
Right, right. Yeah. So we have similar kinds of ways of translating things from the relational model to the document model.
So we have to either sample or set a specific schema for a collection so that it looks like it's a table with columns, right? And maybe we could talk a little bit more about that.
Yeah. So is there is there a requirement to use the BI connector around normalizing your data or providing some kind of hint about how you're representing the data?
That I'm not too familiar with. Um,
How do you even develop such a connector? What kind of technologies are you using? What maybe are you using any of the MongoDB drivers in the process as well?
so I know for the BI connector, a lot of the code was borrowed from existing parsing logic. And then it's all written in Go. Everything on our team is written in Go. It's been a while since I have been on this repo, so I am not too sure about like specific technologies that are used. I don't know if you recall, Evgeny.
Well, I think the biggest thing is the Mongo AST, the abstract syntax tree, which is also built in Go. And that's sort of like, I think what Varsha alluded to earlier was like the big intermediate stage that helps translate SQL queries to Mongo queries by sort of representing things, if you're taking like a programming languages class in university, it sort of represents things as nodes in a tree and sort of like relates like how different, like how you relate like nouns to verbs and things like that in like a more grammatical sense.
Is the BI connector open source? Can people take a look at the source code to see how it works?
It is not, as far as I know. No.
All right, so that's the BI connector. I'm sure there's other connectors that you work on. Let's talk a little bit about the other connectors that you guys work on.
Yeah, maybe what's the most interesting one? What's your personal favorites? I mean, you're probably all working on one separately, but is there one that's like commonly cool and commonly beneficial to MongoDB customers?
Yeah, well, the one I've worked on the most recently, personally at least, has been MongoMirror, and I've actually sort of come to like it quite a bit, just because I think it, has a lot of really cool components. So just like as a refresher, MongoMirror is the tool that we use, or the primary tool that Atlas uses to help customers with live migration. So what this helps them essentially do is they could just be running a database, taking in writes and reads and things like that, and then without essentially shutting down the database, they can migrate over to a newer version of Mongo, like maybe just like bigger clusters, things like that, and all using MongoMirror. And MongoMirror has like a couple stages that it does in order to help with the migration. It does like an initial sync where it just copies, the existing data as much as it can. And then it also records, operations coming in as well and puts them in the op log, which is essentially like another collection of all the operations that are being done on the database while the initial sync is happening. And then it replays this data on top of your destination, the thing that you're migrating to. So it does a lot of like juggling basically with operations and data copying, things like that. And I think it's, a very robust system that seems to work well most of the time, actually. I think, it's a very like nicely engineered piece of software.
So I wanted to comment on this too. So this is a plug to an event that we actually had recently called MongoDB Live for one of our local events, though, for North America. I actually sat in on a few sessions, and there were customer migration stories where they actually used MongoMirror to migrate from on-premise solutions to MongoDB Atlas. It seems like it's the number one tool for getting that job done. Is this a common scenario that you have run into as well, or are people using it for other types of migrations as well? Like maybe Atlas, maybe AWS to GCP, even though that we have multi-cloud now, or is it mostly on-prem to Atlas kind of migrations?
Yeah, so we work more on, maintaining the software itself, having taken the requests from new features from the Atlas team. The people that would know exactly these details, I think, would be the TSEs, the technical services engineers, who are the ones working with the actual customers, and they receive more information about exactly what type of migration is happening, whether it's from like private database to like our Mongo Atlas or private to private, things like that. But I do know for a fact that you have kind of all combinations of migrations. MongoMirror is not limited to a single type. Yeah, Tim can expand more on this for sure.
Yeah, I'd say like definitely migrating from on-prem to Atlas is the number one use case we see. That's actually like the only technically officially supported use case. So there are customers who are doing other things, like they're migrating, on-prem to on-prem, or one cloud to another cloud. So it definitely does happen. But by far the kind of largest use case is migrating to Atlas, and that is the only use case that we like officially test for and support. So
I actually want to dig deeper into MongoMirror as well. I mean, how much data can you move with it at a certain time? Do you typically like use a cluster of these MongoMirrors in parallel to move your however many terabytes you might have in your cluster, or maybe go into the finer details on how it works?
Yeah, that would be cool, but that would be much more difficult. So we generally only spin up one MongoMirror machine. So if we have like a source cluster that's on-prem, and then we have our destination cluster, which is in MongoDB Atlas, we spin up a machine that's hosted by us, or you can run MongoMirror on-prem yourself if you want to. If there are, like, say, firewall concerns, you can sometimes make that a little bit easier. But it's a single process, and then the process itself is parallelized. So it will, during the initial sync stage that Evgeni mentioned, it will copy over all of the data for each collection in parallel, and then it will start building indexes in parallel as well. And yeah, you can migrate over terabytes of data, but it can take a very long time. It can be a long running process. We've definitely seen customers where it can, if they've got very large data sets, it can take weeks to migrate. And particularly the index build phase takes a long time because that's just a very compute intensive if you've got like hundreds of thousands of indexes on a very large data set. But then once the initial sync is over, then we're just in the business of replicating any changes that happen to the source database to the destination cluster.
So when you say changes that happen to the source database, are you talking about changes that might have occurred while that migration was happening,
exactly,
or something else?
Yeah. So while the initial sync happens, we generally we buffer all of the changes that happen to the source destination to a file. So we essentially just save them on disk, ready to replay them once we're finished with the initial sync. So then once the initial sync is finished, we replay everything that happened during the initial sync, and then everything new that comes in, we also start to replay that once that's done. So we keep the two clusters in sync until the user is ready to cut over their application from their source database over to their new destination cluster.
Now, when it copies over the data, is it using the same object IDs from the source database, or is it creating new documents on the destination database?
Yeah, the object IDs are the same, I believe, and this is kind of a requirement because when in the op log, it will say like, oh, this document with this object ID, we need to update it or change it in this way. So when we need to reapply those changes to the destination kind of cluster, then we need to make sure that, like, obviously the object ID matches that we're changing the right document when we need to reapply those changes.
Okay, so there's two sources of data used in a MongoMirror execution. There's the database, the source database itself, and it sounds like MongoMirror is doing, I don't know, a standard find, getting all of the documents from there, transmitting those to the target system, and leveraging an explicit ID reference so that the documents that are inserted have the same object ID. And then during that time, that's going to take a while. This is physics, folks. It's going to take a while to move those all over, depending on the size of the database. So there's a mark placed in, I'm assuming there's a mark placed in the op log, or at least the timestamp of the time that the MongoMirror execution began.
Yep.
And then
exactly
everything
right.
between that time and the completion of the initial sync is captured in op log, and those transactions in the op log are used to recreate the transactions that occurred in the target database.
Yeah, essentially correct. The one thing is, the initial sync phase can take a long time. So it's possible that your oplog, because the oplog is a capped collection, which means it can only be of a certain finite size. So eventually the older entries just start getting deleted when they're not used. So as soon as we start the initial sync, we start listening to the oplog and saving it to the disk so that we have that information saved. So if we start deleting things off the back of the oplog, we don't essentially get lost.
Right. So I guess a word of caution would be ensure that you have enough disk space available to you in order to execute.
Yes, exactly.
In order to execute MongoMirror. That's great. And I wanted to clarify, MongoMirror, it sounds like it's available from the MongoDB Atlas console, right? Because we're gonna execute that from the console. But it also sounds like you said it might be available for on-prem. Is it a downloadable? Is it an executable, a command line?
Yeah, so In general, if you want to migrate into Atlas, then you should use the Atlas Live Migrate service. So that's available on the Atlas console, and it's a kind of click and set it up, and that's the easiest way to use it. There are some cases where, for some reason, you might need to run MongoMirror locally, in which case you can download the binaries and run it locally. Those are kind of rarer cases, and I think that's probably something you should talk to support about if you're concerned that you might want to run it locally.
So in regards to the connectors like MongoMirror, is there anything that you've done recently towards the product, or anything that's coming soon on the roadmap?
So Varsha and I just finished a big epic on Jira, which was titled as Improved Status Reporting. And basically this was a huge collection of tickets that customers had come to us over time. Basically just saying, we wish there was better status reporting here. We wish there was better logging, or I wish the logs gave us a better idea of what was going on in MongoMirror internally. So we basically spent about a month or so, and Varsha spent quite a bit of time on a ticket recently that she can talk about. We just spent a lot of time improving error messages and revealing information that previously wasn't revealed to help users get a better idea of what's going on in the internals of MongoMirror.
Yeah, the ticket I just finished but was working on for quite some time was to provide better logging during the index building process, which happens during initial sync and then again during oplog sync. Yeah, now users will be able to get logs at a collection level, telling them what percentage of indexes have been built on a particular collection, as well as on each host in their replica set. And then also if they wanted to curl that information from the HTTP server, then they could also do that. So that's an exciting addition, I think. And now I'm also enabling that those logs in the oplog sync portion of MongoMirror, which is pretty similar, but probably will probably have a little bit less information, just because we're figuring out which indexes need to be built on a rolling basis, because we're just tailing the oplog and seeing what comes up. And so by the nature of that, there's a little less information on how many indexes can you expect to be built. You don't exactly know from the get-go. But yeah, I think that'll be hopefully a great help to people who are unsure if their indexes are stalled or are just kind of taking a long time to build.
Well, some fantastic updates. I want to thank you all for stopping by. I know we've got an entire set of content that I wanted to cover around the tools that you work on. Mongo import, Mongo export, Mongo restore, Mongo dump. But I think I'd like to give that the time that it deserves. That could be a really healthy discussion. So I think what I'd like to do is get you guys to come back. Does that sound good?
Yeah, sounds good.
Yeah, sounds great.
Well, again, I want to thank you very much. Is there anything else you want the audience to know before we go?
How can they reach out to you? Are you on social media? LinkedIn, Twitter? This is the time to plug yourself.
You can find me on LinkedIn.
I'm trying to stay away from social media recently, so
no problem.
No, please don't contact me.
I get that. I get it.
Yeah, you can contact me. I'll tell you where, on the community forums. So
there you go. Perfect.
Hey, that's great.
If you have questions about the database tools, then you can ask questions there, and I'll probably see it.
All right. So community.mongodb.com. We'll all be there. If you have questions, you can swing by and ask them in that forum. Well, thanks once again, everybody. Tim Fogarty, Varsha Subrahmanyam, and Evgeni Dobranov.
Yes, you got it.
All right. So thanks so much for stopping by. Have a great day.
You.
Thanks again to our guests. Had a great time chatting about BI Connector and MongoMirror. Learned so much. In the meantime, folks, don't forget about the event this Thursday, December 3rd. It's a MongoDB Late Night. It's going to be a blast. Head on over to bit.ly/MongoDB Late Night to learn more about it and RSVP. Chances to win swag and have a blast while you're doing it. December 3rd, 5 p.m. to 9 p.m. Eastern Time. Thanks, everybody. Have a great day.
Thanks for listening. If you enjoyed this episode, please like and subscribe. Have a question or a suggestion for the show? Visit us in the MongoDB community forums at community.mongodb.com.